Okay, so we are going to make Pong. We're going to make Pong in Python. What do we have? We have the pieces, right? We've got everything we really need, mostly. We got the ball that's bouncing around. The ball is a square. It's bouncing around. We have, last time at the very end, just a little quick, we'll go over it again. We made the paddle as well, right? Moves up and down with our key presses. And all that's left, really, is to hook them together. That's all we need, right? So let's make it happen. And to be nice to you, to make this fun and help you pay attention, this is going to be your last programming assignment. What I do today, you will do in the last programming assignment. Just copy it from the lecture if you want. All right? So that is what you will be doing in your final programming assignment of the semester. You're going to make Pong with me. And for that reason, I will not be posting any code today. All right? I'm not going to post any code from today's lecture. If you need something, you will have to either remember it or watch the recording. Okay? So that is your goal. So yeah, let's do it. I don't have any slides because it's just going to be mostly code. So let's build Pong. Let's make it happen. So all right, got a lot of words. Let's figure this out. All right. So we were dealing with this paddle, right? And we made sure that the paddle did not go out of bounds when it hit the top or bottom wall. So let's review the paddle program. Let's go back from last time. This is last programming lectures. Paddle program. So let me run that, and then we'll go through it and we'll talk about it. Okay. So here was the paddle program, and I was pressing the keys to move the paddle up and down, right? So what was this doing? So we got our bounding square, of course, which was our draw rectangle function, 400 by 400, centered at 0, 0 as usual. And then we decided to make the turtle the paddle. That makes sense, right? We stretched him out. We're like, all right, Mr. Turtle, you're going to be a purple paddle, and we're going to stretch you by 1.5 in the horizontally and 6 times vertically, which makes him longer than he is wide. So that looks like a paddle, right? And that's pretty much it. We set the starting location of the paddle. We hard coded that. It's not random. It's like -170 on the x, 0 on the y. It's like perfectly in the middle, centered on the screen because the y is 0, and then the x is just over there and it can never like move left or right. That's like where the x is going to be. Okay, and then like it's paddle x and paddle y. It's going to keep track of wherever we're going to change these. It's never going to be the x that changes though, right? Because the paddle can only ever go up and down. So it's just like the bouncing ball from the first program that looked like this, right? Only messing with the y, and yeah. So we learned that there's a cool feature of the turtle library where we can be like on key press. We can ask the turtle to listen for our keys being pressed. It's got a good ear. And yeah, what that function does is it lets us call another function based on a key. So a key is represented as like a string representation, and it's like, all right, if the up key is pressed, I will call. The turtle will figure that out, will notice that the key has been pressed, or he's listening for it, right? That's the metaphor. And you'll call that go up function. So every time we press the up arrow, we're going to call go up. Every time we press the down arrow, we're going to call go down. And the main job of those functions is, right, you press it once, and it nudges the paddle up or down just a little bit. Just a little bit. And we did it by 10 units, apparently. Okay? So that's where we went, and that's what we did. And yeah, we noticed that we needed to rein the turtle in. We didn't want the paddle to go outside the bounds. So let's remember how we did that. All this code you still have. This has all been posted, right? So that's where we started. And apparently the default turtle size is 20 by 20. So when we stretched him 1.5 in the x, that made him 30. And then we stretched him 6 in the y, that made him 120 wide, 120 tall. So the 120 is the thing that actually matters, all right? Because we don't want the turtle to get any bigger than right here, to go any higher than right here, all right? And so if this is y equals 200, as it is, we don't want the turtle to get up to there because it's always his coordinate is relative to a center. That would bring him past. We don't want that. So what we noticed is, all right, the highest point the turtle should ever get is 200 minus half of that height, because that'll put him right there, right? Minus that 60. So that'll put him at y equals 140. There we go. All right. So that's what we checked for, at least for the top wall. Like, don't let the turtle go outside of y equals 140. If he tries to, bring him back in and just like keep him there. All right. So we used an if statement to see if we hit the wall and not continue. All right. So we usually would we hope that we can move. So we try to change the paddle y variable, but that might have made it like 150 or something, right? So just to rein ourselves back in to make sure we never go out of bounds, we have this little short if statement. It's like, all right, if the paddle y ever gets bigger than 140, that's too big. 140 is the top. So that's as big as you can ever be, Mr. Turtle. I'm going to put you right back there. Okay? So that keeps them in the bounds. All right? And then we finally, these are just variables we're playing with, right? It doesn't matter if this gets to 150 as long as we fix it before we say turtle.goto, right? Because that's what actually shows stuff on the screen. That's where the turtle actually does stuff. So here, if I can press or hold in the up arrow all day long, the paddle y variable is changing to 150 because of this line, right? But we're bringing it back down before we actually put the turtle somewhere based on those variables. All right, does that make sense? So like these variables are just hints for us. They're helpers for us to figure out and plan where the turtle should go. And as this line actually moves the real turtle, right? Are there any questions about that? So that's what the go up functions do. So making enough sense. So yeah, we did the same for the go down. Like, all right, we moved the y in the negative direction. If we ever press the down arrow, that's what we want. Like, we're calling that function every time. And you can hold it in, of course. And we don't want it to be too small either, right? So if we ever make it like, you can imagine it's negative 140 this time. Don't let it be any smaller than that. So like this line may have made it negative 150. Bring it back down so that we're just grazing the bottom there and never go outside, all right? And then finally put the turtle where we plan to put it. Okay, so we made the turtle the paddle, and in the other program we had the turtle be the ball, right? So yeah, I think that was most of this program. So we got this one, right? Up and down, paddle, beautiful. And we have also opened up the program from last time, the 2D bounce program, right? We also have this one, which was moving the turtle in a random two-dimensional direction, right? We had what? X offset, Y offset, and it's beautiful. Look at it. So we have this as well, right? So what should we do? It's about to hit the corner almost. Nice. So we have this, and the turtle here was right. The turtle was a square this time. It's perfect squares, 2 stretched. Okay. So here the turtle was the square or the bouncing ball, and then here the turtle was the paddle. The turtle cannot be both. All right, so we have to somehow combine these two programs and think about this. All right, oops. So here, the turtle is the paddle right now, and the turtle also needs to be the ball. That's impossible to use the normal turtle dot stuff to do that. You can't just like have the turtle be the ball for a frame and have the turtle be the paddle for the frame. That's not very useful, and it would look weird. So what you can do is, the magic of the turtle library, you can have multiple turtles on the page. That's what we need here. So you can have multiple turtles, and there's a concept then of a default turtle. So every time you use the turtle library, Python imagines that you want to have at least one turtle, right? So it makes one turtle. It creates it and makes it be born and everything. So, and then that's what you get when you say turtle dot whatever, turtle dot forward, turtle dot go to. That moves the default turtle, the one that you get always whenever you use the turtle library, all right? If you want more turtles, and we need more turtles this time, they're going to go in just extra variables and give them any name we want them to be, all right? So here is how we're going to change the program. We're going to combine the files, and we're going to say this. If you say turtle.capital turtle, that function births a new turtle, all right? That's what, and then we can shove it into a variable, and now there's another turtle on the screen. You always have the default one, and then the other one here, the paddle, will be a new turtle variable. And now, instead of turtle.goto, it's going to be paddle.goto. Does that kind of make sense? So that's what's going to happen. We're going to make a second turtle on the page, and even a third turtle for the actual bouncing square, right? So we need all those things. So now we'll say paddle.goto instead of turtle.goto, because we want to move the paddle turtle, not the default turtle anymore. Okay? So that's how that will work. And yeah, we'll still like use the default turtle for the key presses and everything. That's fine. But it's going to move the paddle turtle. Okay? So I think that's enough to get started. Let's try to combine the programs now. All right. Boop. Which one do I want to start with? I guess is the question. Let's start with the paddle program. I think that's a simpler program. It's shorter, right? So let's make a new file. I will make a new file at least. You'll eventually be doing this in your lab or in your programming assignment. I'm going to copy and paste the entire paddle program right here. All right. I'm going to save it somewhere that you won't get. All right. I'll save it on like my desktop. So I'll call it pong.py. And so there it is. It's in the entire paddle program. So nothing has changed so far. If I rerun it, it's just the paddle program. There's no ball. And so I want the turtle to be a paddle, and I also want the turtle to be the ball, so I need to make multiple turtles on the screen. So I want to say this, turtle.capital turtle function. Shove that into a variable that creates a brand new turtle on the screen. All right? So let's get started with that. So we're going to have multiple things here. So this is just like turtle-shaped turtle, draw a rectangle, we're drawing the bounding square, and then from here onwards in the program is the paddle stuff, right? All this stuff down here. All that is paddle stuff. And so let's like mark that, because we're going to have paddle stuff and ball stuff eventually. So, all right, the bounding square, draw a rectangle, that's not part of the ball stuff or the paddle stuff, so we'll keep that there. And then here is where we'll section off everything else. We'll be like, all right, this is paddle stuff. Try to center this. Good enough. And so let's just helper little comment for us. We're marking it up. All right, so there's the paddle stuff from here on. And like we said, we're not going to use the default turtle because we want to use multiple turtles. We want one for the ball, one for the paddle. So let's make a new turtle, right? Make a new turtle, be the paddle. We're going to say exactly this. Paddle equals turtle.capital turtle. All right. So we want to not make the default turtle the paddle. We want to make a turtle, I don't know, for the paddle. How about that? And so what we say is just this. We say paddle equals turtle.capital turtle. That creates a brand new turtle, and we save it in a name right there. All right. So now, because we need this as a new turtle on the screen, right? Now we say paddle dot whatever we wanted to do. Paddle.goto, paddle.forward, paddle.left, right? Paddle.right. We say that everywhere. It's not dealing with the default turtle. We want to mess with the paddle turtle now, right? That's what we'd like. So yeah, let me do that. So instead of turtle everything, this is the default turtle messing with the default turtle. We don't want to do that anymore. We want multiple turtles. Now it's paddle.shape, paddle.fill color, paddle.stretch it out with the turtle size, yeah? That's what we need. So yeah, we still have the paddle X and paddle Y variables. We want to put the paddle in the correct starting location, right? So paddle.up, paddle.goto. This is making sense. It's a new turtle variable, right? So it's going to be a second turtle on the screen, you'll see, all right? And then, all right, it's going to be go up, go down, messing with paddle X and paddle Y, and then it's paddle.goto. We're moving the paddle at the end of all that, right? That's what we're doing. And we're still going to use the default turtle to listen for the key presses. That's fine. Just like somebody somewhere is going to listen for our key presses, but the default turtle will command the paddle turtle, all right? There's like tag teaming. So does that make sense what I just did? I mean, a brand new turtle for the paddle. I changed that everywhere. That's what we're going to need, all right? And so I said paddle.shape, paddle.goto. And that's fine. Now there's going to be two turtles on the screen. There's the default one and the new paddle one. Okay? Let's try running this, see if I forgot anything. So it's the default turtle, right, that's drawing the rectangle. Because it's like turtle dot whatever. And then it's paddle stuff over here. Look, now there's two turtles. The turtle on the top left, because that's the last thing the default turtle did, right, is draw the bounding box for the rectangle. And then we have our paddle turtle that is now in the wrong direction. But it's still moving up and down and stopping there now. Cool. Do we have any thoughts as to why that happened? Why is it sideways, but it used to be fine? We can fix it pretty easily, but do you see why it happened? What's the default direction of a brand new turtle on the screen? Like when you start the turtle program, which way does it face? Yeah, east, right. And which way is our rectangle drawing turtle that we turned into the paddle before facing now? So it finished drawing the rectangle is facing up. See that? So everything that we did was relative to that turtle, right? This old turtle that used to be facing up, and then we never turned it around any other time. Do you see that? And so the default turtle, we just need to like turn it and face it up, just like it was the old one. See that? That'll fix it. Does that make sense? So yeah, we can hide the old turtle as well. So yeah, the old one was facing up. This one is facing right, and that just messed with everything apparently. So we need to turn it. All right. So I guess let's do that first. Let's have it face perfectly up. So if it's facing right, if we turn it left 90, that will face it upwards, right? Let's put down, why not here? So it's going to be paddle, right? Paddle dot, turn yourself to the left, please, 90 degrees. And then you'll face upwards. Paddle dot lift, 90. Face upwards. I hope that makes sense. And so now it will be in the right spot. Whee! Beautiful. And it's going to move up and down because it's paddle dot whatever. Paddle dot go to. All these bad boys. Paddle dot go to. Paddle dot go to. And we have the old turtle just hanging out up there, listening for their key presses though. It's the old turtle, the default turtle, that's listening for the key presses and commanding the paddle turtle. It's like it's the boss. So yeah, I think that's not too bad, right? Does that make sense so far? This is exciting. We're getting there. So I would also like to make this default turtle probably not there, right? Though I do love the turtle. He's very cool looking. Let's hide that turtle after it's done doing its job of drawing that box. All right, so that's right here. So after draw a rectangle, this turtle just needs to listen for key presses, and it can do that while it's hidden. So there's a way to hide the turtle. And if you want to know anything about turtle stuff, you can always go to the library. Python turtle. Oh, if I can spell Python right. I want to delete that so that I don't ever search for that again. Python turtle. And it's going to be, just say hide. It's turtle.hide turtle or turtle.ht for short. So that's what we'll say to hide the default turtle. So let's see, how do I want to do this? Oh, that's something I didn't notice. It's a good idea to hide the turtle when you're doing something complex if you want it to like work quickly. Let me write that down because I want to test something. See, it's useful going to the documentation page. All right, cool. So I'm going to say turtle.hide turtle because it's the default turtle that I want to hide right now. All right, so it's going to be turtle.hide turtle. So its job is done now. All right, hides the default turtle. So right after it finishes drawing that bounding square, it will hide itself. Watch, because that's right after the draw rectangle call. There it goes, hidden. And now we're pretty much back to how we had the old paddle program. Right? It's just we changed the variables. Now we're using a new turtle to represent the paddle. Beautiful. All right. And I think that's most of what we needed to do for the paddle. Are we ready to bring in the ball program? Any questions before I do that? I want to copy and paste it. Ready? All right, so that's the 2D bounds program, right? So what do we have? We had the draw rectangle, we drew the bounding rectangle, bounding square, and then all this stuff from here onwards, right? All this was ball program stuff. So that's what I'll copy and paste. Boop. And so it's all gonna, let's put it down here. And that's not paddle stuff, that's gonna be ball stuff. So let's mark that. So after the paddle program is over, there's ball stuff. All right. And so now we have to play the exact same game. This is all messing with the default turtle. I guess technically you could use the default turtle now. We just needed two. So like the old one is the second one, that's fine. So you could kind of keep it like this if you wanted to be lazy, but let's learn new stuff. Let's make a new turtle for also the ball. All right. And so what I'm going to do again is I'm going to say like ball equals turtle.turtle, something like that. Make a brand new turtle for the ball specifically. Okay. We'll have to say ball.goTo and all that. Okay, so that's what we want. So let's make not the turtle anymore. Make a turtle for not the square, but like for the ball. And so you can do that, and the very first line's got to look like this. You got to say turtle dot give me a new turtle, capital turtle. It's like a function call, and then it gives you back a brand new turtle, and you can set it into something. You can call it ball. Okay, make a brand new turtle for the ball, and now it's going to be ball dot shape, ball dot fill color, all that stuff. Mess with the ball turtle now, and I should probably say ball width, right, instead of turtle width, because that would be there's not just one turtle anymore. That would be a little silly. So let's say ball, even for the variable names, do all this. All right, ball x, ball y, ball x offset, ball y offset, right? All that fun stuff. We want to normalize the ball x offset, the ball y offset. Do I still have the math library included up here? Yeah, we're good. Where were we? Here, ball x offset, normalize it. Boop. According to the length of the, divide by the hypotenuse length of the direction triangle. We got that bad boy going there, and now let's move the ball, put the ball right in the correct starting location. Ball dot up, ball dot go to where it needs to go. Yeah, you follow me so far? Just gonna do a lot of find and replace. So all right, it's ball x, ball y. We're gonna mess with. And ball x offset and ball y offset might need to be negated when we hit a wall, right? If the ball's y is a little too small, that means we're hitting the bottom wall with the ball, right? Ball width over 2. Did I do that for the width variable? Yeah. Cool. Do I want to say any of that? Move the ball back inside. I don't want to do that many replacements. That's ball y. Change it to where it should go. Put it exactly right there. The ball y offset needs to flip. So we were going up, we hit the, we were going down, we hit the bottom wall, so we want to negate it, so we go back up again, and off in whatever direction the x was telling us as well. If the ball's y is a little too big, that's the top wall, right? Make it exactly graze that top wall with the ball y variable, and change the ball y offset to now bounce us downwards, and then left or right, depending on the x or y offset. Yeah. If the ball, now we got the left and right walls. If the ball's x is a little too small, that means we hit the left wall. Rein it back in, right? And have it just graze the left wall. That's ball width over 2, right? All those things. Coming back to us, I hope. Ball x, ball width over 2. Ball x. There is a find and replace in the idle program, but I think it's more educational to just walk you through so you can look at the program once more and remember what was going on. That was the right wall, right? If it got a little too big, then the turtle was over here, it was coming to the right somehow. So it's the x offset that needs to be flipped so that we go back to the left. The y offset can keep moving us up or down, that's fine. So coming in up, go out up, that's fine. Yeah, and now draw a frame. It's like, all right, we may need to mess with the ball x variable, the ball y variable, the ball x offset, the ball y offset. Technically, this is now handled in the other function, but who cares? That's the ball x. Gets messed with every frame by the x offset of the ball, right? Same for the y. So that's us moving it in the direction that the direction triangle is telling us to move it. Yeah, we bounce if we hit a wall, and then it's going to be the ball. Hey, we finally figured out where you should be now, ball. Actually, put yourself there on the screen, based on the ball x and the ball y variables, and just for until the end of time, draw a new frame that does that. Use our randomly selected direction triangle to put us somewhere, a little arrow that we picked, and move in that direction, bounce if we hit a wall, and then we figured out finally where we need to go for this particular frame, put ourselves there. All right, so that's most of what we've done. That's kind of a little review of the bouncing program, right? And we made a brand new turtle for the ball this time. Any questions about that so far? Mostly review, but let's see if it plays nicely with the old stuff, because now we should have a paddle and a ball, right? There's the paddle, there's the ball, cool. And it looks like I messed up somewhere, so it's not moving right now. So It's like, oh, turtle X is undefined. Yeah, that's right. I've changed it to ball X. Which line? Line 98 I messed up on. So you can see which line you're on, right, in the bottom there. It's very small. It's like line 83 is apparently where my cursor is right now, LN 83. So if I go to line 98, that's where I made a mistake. Nice. So it was ball.go to ball X, ball Y. There we go. Probably messed up some more, so let's find out. Hey, it looks like it's happy now. Nice. So we got a ball on the screen, and we got a turtle and a paddle on the screen. So there's two separate turtles, right? There was three secretly. There's a secret turtle hidden right here at the top left, right? We got the paddle as a turtle that can move up and down with the keys, and we got a ball turtle. They're all working together, but right now they're not talking to each other. See that? So yeah, not too shabby. Are there any questions about what got us to this point? Does it all make enough sense? Think you can do it? All right, so just to make our lives easier, we should probably have a different color for the ball. So like the paddle was purple based on its fill color. We can change the ball's color to something else. Just change it to like blue, something like that. And then it was also moving a bit slow. I feel like the game would be more interesting if the ball was moving faster, right? Eventually, once we hook things up together, because that's a little very easy, right? The game's going to be very easy to make work. So to change the speed of the ball, that means change the size of that arrow that was our direction, which means change the length of the hypotenuse of our direction triangle. Yeah. So that was all this right here. We took care to make sure that hypotenuse was length 1, like move 1 unit every frame. But if I multiply this by like 2 or something, now the length of the hypotenuse is like 2. And so it's going to move twice as fast as it is right now. And maybe that's a good speed for the game. I don't know. You choose. Make it times 10 if you want it to be a very difficult game. I think that's decent. That's a decent speed. And yeah, right now, the paddle and the ball, they're not hooked up. Due to a weird quirk of the turtle library, if you hold in the key, it makes the ball move slower because it takes some processing time to deal with the key presses. Like there's a million happening every second if you hold in the keys, right? And so I guess that's a way to cheat. There's a way to fix that, but it's a little complicated. It's outside the scope of this class. So surely there's a way. Well, let's see. Yeah, I think that's most of what I want to say. So we changed the color of the ball. They're all together, right? They're all working. Secretly 3 turtles, 1 listening for the key presses up in the top left. Got a paddle turtle, paddle.stuff. Got a ball turtle, ball.stuff, right? And really the last piece of the puzzle is to hook them together, right? Hook them together and let yourself lose the game too, right? So if you ever hit the left wall, that should stop the game. Say game over if you want. But I think that is most of it. Are we ready? Are we ready to hook them together? Make them work? Make the paddle hit the ball? Let's see what needs to happen. So, okay. We've got, I guess I want to do some other things, because this is a very important bullet. We want to start the ball on the right half of the screen, because watch. You may start the game in a way that is unwinnable. It's like, what if the ball, because it's random, right? What if the ball randomly picks to start right there and moving left? Yeah. You've immediately lost the game, then you get angry, and you break the computer. Let's see if I can get anything like that. But a very quick and easy solution to that would be to just make sure the ball always starts its life on the right side of the screen. Because right now it's allowed, due to these randoms right here, to start on the left side of the screen as well. But we're just randomly getting lucky right now. I'm trying my best to show you an example of this problem. It's got to start on left and move left. So imagine it was moving left right there. I'll try one more time, but you can imagine that it would happen eventually. You'll get really close to the left-hand side, outside the paddle, right there or something. Something like that, but if it was up a little bit more. You immediately lost the game, right? So let's make it so that that doesn't happen by starting the ball somewhere on the right side of the screen. Could be up, could be down. Even if it moves to the left first, we'll have some reaction time, right? So the way to fix that is just take the x coordinate, right, of where the ball begins its life. The y could be anything, but the x coordinate, let's make sure, because this is 0, 0 in the center, right? Let's just make sure the x coordinate is always positive or just never negative, yeah? that would be perfect, right? That would make sure, that would force the ball to start its life on the right half of that screen. Does that make sense? And that will make it so that the game is more or less winnable, right? You can't lose unless you really want to now. So yeah, let's do that. By changing the x coordinate of the ball. Don't let it be negative. Just be like 0 onwards. Then it will always be on the right half of the screen, right? Positive or 0x. So this is start on the right half of the screen. You can get fancy by changing, like making sure that your direction is always to the right. If you want to do that, there's a way to do that. Just like make sure that the x offset is always of your direction. Make sure that's never negative, because that would be moving to the left. But I think that's less fun. Let's just let it shoot off in any random direction along a circle. But at least the ball is always on the right side now. It's always going to start its life on the right side of the screen. Okay. Boop. And it may move to the left, but it's always going to start on the right. Beautiful. All right. So that's good. And now I just need to let them hook up together so that if the ball ever hits the paddle, it will bounce off. That's very important. Okay. So, all right, we're ready. So let's make. Or I guess it's easier to do the game over first. Why not? Let's do that in the order that I planned it. So okay, let's save the bouncing off the paddle for last. So the next easiest thing to do, second to last thing we need to do, is sure we can hit the paddle, right? If we bounce off the paddle, we do stuff, right? We need to bounce the ball off. But if we lose the game, right, that means the paddle hit that left wall. We missed it, yeah? That means that we lost, and we should have, like, the game stop. So if the ball ever hits that left wall, the left wall is special, right? That's the wall that we should have, like, fielded, and we should have caught the ball or, like, deflected it. If we did not, if we let the ball hit the left wall, that should stop the game. So we better notice that and stop the game, all right? Does that make sense? That's what we want. So let's do that first. So if the ball ever hits the left wall, it's game over. We have, look, we have a left wall hitting if statement already. We just need to change this, right? To, like, if the ball hit the left wall, we don't have to do any of this at this point. Just, like, stop the game. Does that make sense? We'll just let it stop the game, and we'll be off, right? That will fix everything. So just, like, hook into this. If we ever hit the left wall, it is game over. And let's just interpret game over. There's ways to show, like, text on the screen. You can actually print the word game over if you want to. But just to make it easy for ourselves, let's just make the ball stop moving, because that will, like, indicate that the game is stopped, right? So I think the best way to keep track of whether the game is on or not is, like notice that we stopped the game, is to just use a variable, right? Set to true or false. True if the game's still going, false if the game's not, or let's do it opposite. Let's make an is game over variable. And it's false when we start the game, right? The game is not over once we start it. But if we ever hit the left wall, then is game over should become true, right? We should hook into that and have it stop the game. So let's use that. While the game is not over, let's keep on trucking. And so we need that variable. Let's use a variable to represent whether or not the game is over right now. All right. And so I guess we'll put it right here. Why not? So I'll say is game over. And let's have it be false, right? So at the beginning of time, the game is not over, right? Not over. And we would like to continue the game as long as is game over is false, right? Or think about that. As long as not is game over is true. Does that make sense? As long as that is a true statement, as long as the negation of is game over is true, that means game over must have been false. We want to continue the game while it's not over. See that? It's like a double negative. So, and this is the loop that repeatedly moves the ball, yeah? That's where we could hook into the is game over variable. We'll just be like, all right, while, not forever, not while true, because the game might eventually stop, while the game is not over, right? While the game is not over, that's kind of what I want to put here, right? And I'll use my variable. So it's is game over, while is game over is false, right? Something like that. While is game over is false. Alternatively, I can be like, while not is game over is true, right? Because the negation flips it. And then also, you don't need the equals true. That's redundant. It's like This loop continues if this evaluates to true, and so if is game over is false, right? We want it to continue. So if is game over is false, the negation of that, not that becomes true, and so this evaluates to true and it runs the body. That kind of makes sense. So the equals true is redundant. It's like while, and you can read it kind of like English, like while the game is not over, do stuff. Does that make sense? That's what we want. All right. And so nothing has changed because I've never changed that game over variable. But now I have it. All right. So while this game over is false, and so it's always false because I'm never changing it right now. But like I guess it should have hit the paddle for that example. But let's have it miss the paddle, like right there. If that happens, we hit the left wall, we should change this game over variable to true, right? Because then the negation of true becomes false. So it's like while not true. So while false should not continue the body. That will stop the while loop. All right. So that at that point we're set, and it won't continue the movement of the ball anymore. Okay. So that's what we hook into. All right. So if we ever hit the left wall, it's this one, right? It's up here in bounce if hit wall. So like here's that function. Here's the left wall hitting if statement. The x got a little too small, and we try to go past it. So we should probably move the ball back inside. That's fine. But change the x offset, that doesn't really matter anymore because we're going to stop the movement, right? So you can delete maybe not this one because you want to keep the ball inside the bounds, but maybe this one is fine to delete. I'll keep it there for posterity. But like if we ever get to this if statement, right, we miss the ball. Yeah, it should have bounced off the paddle. We did not field it properly. So this is the game over, right? This if statement notices that the game is over. Stop the game by setting the is game over variable to true now, right? It started out false, and this is the one place it notices that the game is over, and we will set it to true. Does that make sense? And then, this is a global variable, so I have to say, like, because I'm messing with it, global is game over. And that is where I set it, right there, and that's going to influence that final while loop that was always moving the ball every frame as fast as it could. Now when the game is over, it's like, all right, this is true, while not true, so not true becomes, the negation of true is false, so like while false, when a while loop condition is false, it stops the loop. Yeah. And for that, my friends, we'll fix it all. We notice the problem right here. We set it to is game over true. Oh, that is the worst initial direction. We set it to true when we notice it. There we go. So I'll miss it. Boop. And it stops the game. So like we set it to true right there. That's where we notice, right? We hit the left wall. And that stops this loop because not is not true is while false, right? The false condition, that stops the loop. So because the while loop continues as long as the condition is true, it's finally false, right? So that will stop the game. The paddle can still move because that's not controlled by this while loop, but the ball has stopped, and that has effectively ended the game. So yeah, a new variable and a new like addition to our if statement, and messing with this loop will do that. Any questions about how that works and why it works? It's just so fun. Yeah, that's how that's going to work. And we are so close. So now the last piece of the puzzle is we want the ball to bounce off the paddle if it ever hits the paddle. And in particular, we want the ball to hit the right side of the paddle, right? That's the only side that we care about the ball ever hitting. That's important as well. Like you can, I mean, if you want to get fancy, you can have it like hit the top part of the paddle if you want it to. That's a little too complicated, I think. We'll just like have it hit the right side of the paddle. That's the only side it can hit, right? So yeah, that's what we want. And we will make the ball bounce off if it ever happens. And so just like, we want to make this easy on ourselves, right? Just like we made this function in draw frame, it's like, all right, bounce if we hit a wall, right? That was nice, that was easy. That lets us fully understand the draw frame function, right? Because it's like all the logic of dealing with whether or not we hit the wall is right there. It's packaged together neatly. We don't have to care about this unless something's wrong. We can go look at it then. Let's do the same for if we hit the paddle, right? So bounce off the wall if we hit the wall. And then also, maybe we hit the paddle, so let's like make a little function that does the same, right? So like if if we hit the paddle bounce off. Let's make another function. And that will like save us some thought, right? Because it will make a lot of sense what it's going to do. So if we hit the paddle bounce off, so it's like bounce if hit paddle. See, if we had that, it would be very easy to understand. Okay, yeah, this is correct, right? Like do one of those things. It's never going to hit both of these, so we're good mostly. Like handle them all, and that will fix it. So yeah, let's just, if we made this function and it did the right thing, this is where we should call it, right? To notice and like have the ball bounce off. If so, we're good to go. Yeah. So that's what we need. We need this function now. So def bounce if hit paddle. And this is where all that thought is going to go. It's like notice that we hit the paddle. In this function, we need to notice that we hit the paddle and deal with that, right? And make sure that we understand what just happened. Yeah. So that's going to be it, right? So like what goes here? Some complicated stuff, because like we need to notice first. It's going to be some if statements, right? Notice that we hit, like the ball's right here. We just grazed it, right? It's right next to the paddle. It's close, it's moving in towards the paddle, right? The right side of the paddle. And then it needs, like, it was coming in this way. We need to shoot it off this way, just like if we hit the left wall. So the same kind of, the logic is going to be very similar to whether or not we just hit the left wall, right? You can steal a lot of that. Though we changed the left wall to make game over. Now we don't want the game to be over, of course, if we hit it properly. Bless you. So yeah, I think that's mostly it. So let's figure this out. All right. Well, let's figure this out. How do we know? How do we know if we hit the paddle? It's like if we hit the paddle, bounce off. That's essentially what we want, right? That's what the statement should be, right? If we hit the paddle, if the ball hit the paddle, bounce off. Like if we could write English, that's what we want, right? You have to somehow turn that into code. Well, let's figure that out. So like what is our condition? How do we notice that we just hit the paddle? We got a bunch of variables, right? We have several variables that tell us where the ball is at any point in time. That was ball X and ball Y, right? That's telling us where the ball is, its center at least, and we also know how big it is, how wide it is. We can use all that to tell us where it is. And then same for the paddle, right? The paddle knows where it is as well. It's got the paddle X and the paddle Y, yeah? And then its center is there. And then it also has like a width and a height, like 30 by 120, if you remember all that. Those are our variables that tell us where the paddle is, yes? And the ball. So like those together, we have to somehow combine them, right? It's going to be a check on both of them. It's like, are they both in the right place at the right time? Yeah? So here's what's going to happen. It's like this is what we want. We want to notice the ball hitting the paddle, just like this. Here's the paddle. And then, I don't know, here's the ball. How do we know when one hit the other, right? So again, they're both, like, we know where they are. We know where their centers are, at least, using, right? We know that this is right where, wherever it is, it's, oops. The paddle, where's the paddle? These variables tell us, right? Those variables are always changing to tell us exactly where the center of the paddle is. And that's what we're using to actually move the paddle eventually with the paddle.go to. So paddle X and paddle Y tell us exactly where the paddle is right now. Wherever it is, it's at paddle X and paddle Y. Yeah? We know that? And then same for the ball, right? Wherever this ball is right now, I have some variables that will tell me. It's ball X and ball Y. They're always keeping track of where the ball is right now, and that's what we're using to eventually put the turtle ball, right, in the right spot on the screen. These are just variables that keep track of that, though. Ball X and ball Y. Okay? So there are those two things. I've got ball X and ball Y. There. And I also know the width and height of all these bad boys. So like I know that the ball width is 40. We've calculated that idea. This is 40, this is 40. And then the width and height of the paddle, it was stretched. This is 30, and this is 120. Let's put the 30 up here. This is 30, this is 120 tall. Okay? Those are very useful things we need, all right? So when we hit, right, when the ball has just grazed the paddle, what is true about their locations relative to each other? Right? That is what we're trying to figure out right now. So what is true about their locations relative to each other? So if they are just grazing, they're just touching right there, what is true about their x's and what's true about their y's? So let's think about this. So if they are just touching like this, their x's are this much apart, right? Whatever that amount is plus whatever that amount is. Does that make sense? They're exactly that. That's exactly what they must be, right? They're that width plus that width. That means they're exactly touching. Yeah, that's how far apart they must be. Can't be any bigger, because if it's bigger, it'd be over there, right? So whatever that x amount is, that tells us they're exactly grazing each other right there. So that is going to be half of the 30, right? So 15, plus half of the 40, which is 20, right? Does that make sense? So it's going to be, there are 35 units apart on the x at least, if they have just grazed each other. Does that make sense so far? We need that. So like that's how we know like the x's are okay. And then we need stuff for the y's, right? So now the question is like, what is true about the y's of the ball and the paddle if we just hit it, right? If we just hit the paddle, just hit the ball. We need to be careful, right? Because the y shouldn't be like, this should not be our only if statement, right? Are they close enough on the x? Because like, what if the ball's up here, right? I mean, they're perfectly close enough on the x, right? But the ball's about to pass the paddle, yeah? So we have to also have a condition on the y's, yes? So now we have to decide, what is the topmost point at which the ball has still hit the paddle? So you can make some, like, this is up to you as the programmer right now. Do you want to make this the topmost spot at which the ball hits the paddle? Maybe your answer is yes, I'm not sure. Let's try to make it easy on the user. Let's say that the topmost point at which the ball has hit the paddle, let's have it still bounce off, is if it just grazes that corner right there. All right? You can make it hard mode by not doing that, by making this the topmost spot. But let's say that this is the topmost spot at which the ball has hit the paddle. Does that make sense? And now we need to figure out y's, because it's y that tells us that. Yeah. So what's true about the y if that is where we hit it, right? So okay, it's the distance, right? Because it's always relative to the center. We know the center of the ball. We know the center of the paddle. The distance between the paddle and the ball right now, if that is where it's hit, right, the very topmost spot, is this distance, right, plus this distance. That summed together will give us as high up as the paddle could be, right? As high up as the ball could be. Does that make sense? That's what we want. So what is that? What is that number? Let's figure this. Like, this is the topmost line at which the ball could be relative to the paddle, kind of. That's what we want to see. So something like that. Like, what is that distance? It's going to be 60, right? 60 plus 20, so 80. That's as high up, the offset. That's how much the ball can be offset in the y direction from the paddle. Does that make sense? And then the same is true in the other direction. It's like, all right, the lowest point at which the paddle can hit the ball, right, is right here. Boop. And what's true about the y's there? Well, it's this height again, right? What are they offset by? It's like, all right, the center of the paddle, that distance, plus the center of the ball, they're max that far apart, right? That's going to be another 80 units apart, okay? And so do you see how the y can be anything between here and here for when the ball hits the paddle, yeah? The y can be anywhere, because like it could hit here, that the y is between that spot and this spot, yeah? We can calculate it relative to the paddle. And then, like, when that's true, right, the ball could be over here still, could be down here still. We also want to check if the x's are close, right? It's a condition on the x's and the y's at the same exact time, because we don't care that the ball is up here, down here, right? That's still true relative to the y. We want it also true relative to the x, right? Make sure that the x distances between the paddle and the ball. Then we know we are both grazing the paddle, and then also we're within the bounds of hitting off the paddle. Yes? So it's a condition on the y and on the x. Make sure it's not too far away in this axis and not too far away in this axis. Yes? That's what we need. Do those ideas make sense to us? because it's going to be a weird calculation involving those variables, and I want you to see it, right? But that's mostly it. So bringing that all together now, we know the ball touches the paddle when all of the following are true, right? The ball touches the paddle. Here, let's save me some room over there. The ball touches the paddle when the x's are close and the y's are close. Kind of what I just said, right? So let's work on the x's, right? So what is true about the x's when the ball has touched the paddle? So that means this distance, right? This exact distance is how far apart the ball and the paddle are, right? This exact distance, 15 plus 20, 35. So here. It's always relative, right? Because we don't know where the paddle is or the ball is. It's like those variables are telling us where it is. So like the distance is offset using those variables. Okay, so it's like, all right, the ball has touched the paddle when it is this exact distance away from the paddle. So like when the ball's x is exactly this much apart from where the paddle x is, right? It's start where the paddle is and move that way. That's as big as the ball's x could be. It's like it's equal to take the paddle x, right? Start here and move over that amount. Paddle x plus 15, right? Plus 20, that'll get you right there on the x. Does that make sense? So start where the paddle x was, here, go 15, go 20, that'll get you right there. That's where the ball should be if it just hit it, right? Paddle x plus 15 plus 20. Does that condition make sense? A mathematical condition? It's like, all right, that is exactly where the ball is when it's just grazed the paddle. Started the paddle x, here's paddle x, plus the 15 puts us there, plus 20 puts us there. That's where the ball's x should be. Yes? That's it. And then also, due to the way that we're moving quickly every frame, like maybe it went a little inside of the paddle, that's okay. Just a tiny amount. So we should change this to be like less than or equal to, just like we did for everything else. That's the right answer there. Because it might not exactly ever hit, depending on how fast you're moving. So that needs to be true about the x. But like, all right, what if the ball was right here? We don't want it to hit the paddle. So we also need conditions on the y's, right? So the biggest y that we could have, right, and still hit the paddle for the ball is right up there. So, all right, what's true about that? All right, we want the y of the ball to be here or downwards, yes? That would tell us that we're within the range for the y at least. So like, all right, the ball's y, if it's exactly hit the top part of the paddle, it's right there. What's true about that relative to the paddle's y? It's equal to, well, start at the paddle's y, go up 60, and go up another 20. That's the topmost bit of where it could be, right? So start at the paddle's y, go up 60, and then go up another 20. So like start there, go up 60, go up another 20, because that would put you at the topmost spot. That's the y coordinate of where the ball should be, right? And it could be like anywhere there or downwards, right? That's okay. Less than or equal to, because we're also going to have another condition here and upwards, and that will like close it all off. We want all that to be true at once. Right? So that's where it should be for the top part at least. Does that make sense? Does it make sense how I came up with that calculation there? So like, all right, that's as high as you could be. So like, what is that distance? It's like, all right, start at the paddle's y, go up that much and up that much. That's as high as you could be and still hit be hitting the ball. And then same is true kind of for the bottom, right? How do we know when we graze the bottom when the ball's right there? If we're at the bottom, we're exactly equal to the paddle's y, go down 60, right, half the height, and then go down another 20. That's where it would be when it just hit the bottom. So start at the paddle's y, go down 60, and go down another 20. All right, that's when we hit just the bottom, but we want that to be like from there upwards, right? That's what we want. We want it to be from there upwards. That means we're hitting it. So that or that. So I'm going to make that greater than or equal to. Right? The ball's y should be greater than or equal to this, and then also less than or equal to that. So it's both at the same time. Does that make sense? Like the ball has touched the paddle when all of these are true. So like looking at the y stuff, it's like, all right, the y can be from here down or from here up is what these two are saying. Does that make sense? Like this is as big as the y could be. We want it to be equal or smaller than that, so that'll rein it in on the top there. Like cut it off right there. And then the same for this. Like, all right, this is as low as the paddle could be, or as low as the ball could be. It could be anywhere above that as well. And so that's cutting us off at the bottom. It's drawing that line. Does that make sense? If those are true at once, that means we're within the valid range of hitting the paddle. Yeah, with the ball. That's what we need. And then the same is true. We want it all true at once, right? The x has got to be this as well. So right when the x is this, and the y's are that, that means we're within the range from here to here, and we're also just grazing it right here, right here. We're along this line exactly. That's kind of like picked apart this exact line. That's where we're saying we can hit the ball. Does that make sense? That's what we just picked apart. When all three of those things are true at once, we know that the x is in a good spot, like it's not over here somewhere. Even if it was in the y, the x is not like over here somewhere weird. Then also the y's are within this range. We are set. All right? Are there any questions about those conditions and how we found them? So we want all three of those things to be true at once, right? Only if all three are true, then the ball's in the exact right spot to hit the paddle. And we should deal with it bouncing off. All right, so let's find that. I think we want all of these conditions to be true all at once, right? You can make one big if statement, but there's got to be a simpler way, right? So here, this is our bounce if hit paddle. Like if the ball hit the paddle, bounce off. So let's take this condition, because that's this condition, right? If all three of those things are true, that's when we know the ball hit the paddle. Let's turn these into like three different things. Let's call this thing A, condition B, condition C. Let's set here A equal to whether or not the ball's x is less than or equal to the paddle's x, plus 15 plus 20. And then B is whether or not the ball's y is less than or equal to the paddle's y, plus 60 plus 20. And then C is very similar to B. C is like, all right, the ball's y is greater than or equal to whether or not that's true. Paddle's y minus 60 minus 20. So those are my three conditions, A, B, and C, right? We want them to all be true at once. Like this will become true or false. This will become true or false, or this will become true or false. We want them all to be true at once. It's like if they're all true at once, then the ball hit the paddle. So if A is true and B is true and C is true. See that? That will only run the body if all three of these came out true, right? Because if one didn't come out true, like maybe it's within the range for the y's, like both of these two are true, but if this one's false, that means like the ball's way over here somewhere. It has not got to the right spot yet, right? So we want all three to be true at once. Only once all three are true, we are ready to bounce off, all right? Does that condition make sense? Are we ready to code the last bit? Turn that English into code? All right. So what do we know when we get here? We hit. We finally hit the paddle. So we hit the paddle if all three of those conditions, are met. We did it finally. Oops. Where was I? Come on. There. All three conditions are met. So now we're looking at this kind of. We got the same kind of setup as we did for the left wall, right? Something like this. So let's see. We may be like this, right? We're coming in. We notice that we just grazed, right? We just grazed that right side. This is the right side of the paddle, pretend. And we want to bounce off then this way, right? It's the same stuff for hitting the left wall. It's like right here was our direction. We were moving a little to the left and down, kind of, for this example at least. We're moving left and down. We want to shoot off, still down, but now right. So it's the X offset that needs to be flipped, right? So that's what we did in the left wall. So like it's this code. But the game is not over. Like all this code, this was the left wall code. It's pretty much the same. We want to like, maybe we try to go a little bit outside of the paddle. Like we try to move a little bit too much all at once. Like we're in here somewhere. We still hit, right? So if that ever happens, like make it just graze, just like we did for the wall. Just have it just graze, bring it back, exactly hitting the wall right there. And then shoot off by negating the x offset. So like rein it back inside the paddle, just grazing it, and then change the x offset. So we move to the right now. Okay. So that's kind of the code we want to copy. It's like don't change the y offset, but it's the x offset that needs to take us off in the other direction, in the right direction, right? So that is mostly what needs to happen. So just like this, we may have gone a little bit inside due to like moving too much every frame. We may have gone a little bit inside of the ball, but that's fine. We're checking for that with a less than or equal to. That's okay. If that is true, that's what we want, right? That's what we want to do. So if all those conditions are met, we hit the paddle. Yay. If we tried to go past the paddle, because like we're moving 10 units every frame or something, like maybe we started here and like we moved into here in one frame, like that happens. Just rein it back in, make sure it's exactly grazing it so that we never show the user that it tried to go inside. We try to go past the paddle, move the ball to be just touching the paddle. Like if all that's true, maybe we try to go a little bit inside. That's okay. We want it to be exactly touching it. So like we want it to be like the x to be exactly equal to the x for the ball to be exactly equal to the paddle x plus that plus that. That's what we want, right? And that's a condition on the x, all right? So it's balls x may have been a little bit too small, right? So let's make sure it's exactly equal to this. That's exactly grazing it in the x direction. Yeah, that's fine. That's what we want there. So the y is just like, was it within the range to be hit based on the x? So there's that. Rein it back in. And then we've noticed that, all right, we hit something on the left side, because this is like this is the right side of the paddle, right? It's kind of like a left wall hit, which means it's not the y offset that needs to change, it's the x offset that needs to change, just like we were doing up here. This is like the right wall. See how it's the x offset that's changing, the left wall is the x offset that's changing. That's what we do. Take that. Boop. That's what we want. It's like bounce off, right? Bounce off by flipping the x offset for the ball. And that was this line, right? X offset needs to change. And these two variables live outside of this function. They are global variables. I would like to mess with them inside the function, please. I don't want to like shadow them by making a brand new variable with the same name. I gotta say global those things. Global ball x. I want to mess with that outside thing. I want to mess with this too, please. There. These are local variables, a, b, and c. Right? So if all of these things are true, the ball is just grazing the paddle, or try to go a little bit inside of it, and then the y's are good as well. It's like within the range of hitting the paddle, just like we talked about. If all of those are true at once, bounce. We did it. This is what's true when we hit the paddle. When the ball hit the paddle, if all those are true at once, if a is true and b is true and c is true, we try to go a little bit inside the paddle, put it and make it graze just perfectly, and then flip the x offset so that it bounces to the right now instead of to the left. It could still be up or down. Doesn't matter if it was up or down. Keep the y offset the same, and we're good. All right. I think that is most of the words that I wanted to say. Does this function make enough sense to us? Because that was the last piece of the puzzle, wasn't it? It's like, all right, every frame, like forever, as long as the game's not over, draw a new frame. It's like, that makes sense, right? Mess with the ball, like move it, nudge it a little bit every round. And then, all right, if we hit a ball bounce off, deal with that. If we hit the paddle bounce off, deal with that. This wall might stop the game, but like if we're still in the game, like bounce with the paddle. And now we finally decided a new spot for the x's and the y's. Actually draw the ball there. That's pretty much it, right? So, all right, moment of truth. Let's see. All right, let's see what I can do. Oh, yeah. That's beautiful. Oh, I hit the corner, too. If that is ever true about the x's and the y's and all that fun stuff, bounce off. That's gorgeous, isn't it? And then we can still lose the game. because like it wasn't within the Y's, right? The X's were close, but it wasn't within the Y range of the paddle. Nice. And every game is different, right? It might be a little bit faster. It might be more left and right than up and down. That's what we noticed. If all those things are true at once, let's see if I can have it hit like a little bit outside the range. No, well, kind of. I want a better seed to show that to you. I want more left and right, please, ball. Oh man, your cheese keep going up and down. You can mess with the direction by changing the way the random numbers have. There we go. That's good enough for me. So here, didn't hit all of the paddle, but it hit enough of it. Like we were allowing it to go up into the corner there. Not hitting all the paddle. See, it just hit the bottom corner there. So that was part of our calculation. That's beautiful. Of course, you can hit it dead on still. That's fine. And we still want to be able to lose that game. So here, if the Y ever becomes too small, or if the X becomes too small and the Y is out of range for all this to hit, like this, that'll be false when it's down here, then we'll still notice in the wall, right, the wall code that, all right, we're a little too small, game is over now. I think that's most of it. Yeah, and you can change the speed, right? Change the speed of the ball in the game by like multiplying this by something other than 2, make it faster. You can cheat a little bit right now by holding in the keys. But yeah, let's kind of review. Whee! Well, let's attempt to review at least. So here, we got, one last time, we got a bounding rectangle, right? We drew that. We try to play the game at the same time. Can't. Got a bounding rectangle. We've got, that was the default turtle drawing that. We hid that turtle. Then we made the paddle as a brand new turtle, right? It can move up and down, just like that. We gave it a starting location, and then these go up and go down functions get called every time we press a key. You can hold in the keys as well. Like the default turtle's listening for those key presses and dealing with that. And then the ball was dealing with everything else. The ball had the hardest code. It's like we made a brand new turtle for the ball, stretched it out, gave it a color, gave it some starting locations and some starting directions, right? I'm about to lose on this. Give us some starting locations and some starting directions. And we're also going to use this is game over variable to keep track of whether or not the game's over. And that's what's happening in our draw frame, right? While the game is not over, keep doing stuff. Whee! Keep doing stuff, right? And so yeah, what do we keep doing every time we continue the game, right? We keep doing this draw frame function continuously. We would like to mess with, because every frame the ball is moved. The ball's got an X offset and a Y offset and a position, an X and a Y. So like we have the X and Y be affected by the X offset and the Y offset every round, right? That's this stuff. But sometimes that was a little too much, right? When it hits a wall or when it hits the paddle, the ball X and ball Y don't want to be these things, right? They're either too small, too big, or they just grazed something we need to change, like the X and the Y offsets as well. So that's the wall hitting code that deals with that, as well as the paddle hitting code. And then once all that has like been checked out, like maybe we have a new spot now for the ball to go, potentially not the same as this anymore. We had to rein something in, but maybe the offset has changed as well. Then actually draw the ball in that new spot. All right, that's what GoTo does. It actually puts something on the screen. These variables were just variables. They're used for us to make things easier on ourselves. So yeah, every frame we hit a wall. This is what's true, right? Either the Y is too big or too small, or the X is too big or too small. We lost the game, right? If the X was too small, finally. That's what we changed. We added that. So like we lose the game if the X is too small. Here, I'll lose the game. No, I'm just too good. And then we also hit the paddle, right? Bounce if we hit the paddle. If we know something's true about the paddle, we will bounce right off of it, just like this, right? By reining it back in, potentially it tried to go outside of the paddle, a little too far inwards, but if this is true about the X's and the Y's, we hit the paddle, we can bounce off, change the X direction, that's what it means to bounce off. And yeah, if you ever miss, that means this has happened, kind of. Due to a quirk in the way we're calculating things, you can kind of hit the bottom in a sense. It's a little weird like that. You can have another calculation to deal with that. But eventually, if the X gets so small, we hit the left wall, and we're not within the proper range of hitting the paddle, then we'll set is game over to true, right? And that will stop this loop, because the loop was going as long as this game over was false. And now finally, the negation of true, because this game over got set to true, not true is false, and so we see while false there, and while loops stop when their condition becomes false. All right. So yeah, but until then, keep drawing a new frame that just kept doing all this. Nudge the ball based on its offsets right now, potentially change the offsets and rein the ball back in if we hit the wall or the paddle, and then actually put the ball in that new spot every frame as fast as humanly possible, as fast as Python can do. All right, that was our frame rate. All right, and that, my friends, I think is everything I wanted to say about this program. Are there any questions about it? Do you see all the pieces coming together? It is very satisfying to get it working, and because of that, this is your last programming assignment. And that's pretty much the last thing that I wanted to say about it. So you will do this, all right? You're going to do this in your programming assignment, get it working, get it fun. I'm not going to give you this code, but you'll just kind of copy what I was doing in class. If you want to, like, you can make it your own by changing the colors of things. That would work, all right? And yeah, change the speeds as well. I told you where to do that. That's pretty much it. So here, release. This will be due next week. There's only 1 week left of classes, so this will be due next week. And that's it, right? May 15th, right there. This is what I want from you, all right? So you, for your last programming assignment, you're going to do exactly what I did today, at the very least. I think it would be very educational if you try to do more, right? Add maybe, like, you can add text in Turtle Land. Like, say game over with an exclamation point and a sad face or something. And you can change it as much as you want, but implement Pong, please. Following my steps. You can change however you want, as long as you still have what I put in there. Like, have Pong, right? Make it 2-player if you want. You've got your library documentation you may want to look at. And then, yeah, as usual, I want you to upload a video, please, going over the code. So prove to me that you didn't just blindly copy it, right? Even though that may be what you start with. Prove to me that you understand it by explaining the code to me, please. And that's what will give you credit. And I think that's everything that I wanted to say about the programming assignment. So you know what it's due, you know what you're going to do. Are there any questions about it? All right, that's all I got.